Alright, FST, time to get serious about review for the final. Here's some stuff I did in class from those selected old tests. I put the chapter up here in the corner so you can kind of follow along. One class saw this already. One class will see it tomorrow. Then I have some more I'll just do on video that I won't have to worry about doing in class. Okay, this is from chapter 4, and I decided to leave the questions on here from the tests that were uploaded. So if you want to follow along, there you go. In a circle diameter 24 inches, I'll give myself some more room here. A sector is formed by a central angle of 135 degrees. Find the area of the sector to the nearest hundredth of a square inch. All right, so we're talking about a circle, diameter 24. Well, that's not as important as radius 12, so let's just say that. Sector is formed by a central angle of 135, which looks something like this. That's what that means, if you forgot. Find the area of the sector. So we're talking about finding the area of this whole thing here. Find the area of the sector to the nearest square inch. All right, so you have a formula for that. It's, well, you actually kind of have two formulas for that, but the one I think you're going to remember the most is degrees out of 360 times, we're talking about area here, so we're talking about pi r squared. If it were arc length, we would have done 2 pi r here. All right, so the degrees is 135 out of 360. You might be able to just sort of notice that that's 3/8 here. Pi times r, see how we needed r and not diameter. Okay, I'll just use the new calculator for that, and isn't that pretty? It's 54 pi. Okay. I like 54 pi, but if you want to decimalize that, you can. Because it doesn't specify. In geometry, make a big deal out of that. All right, so identify each of the following for the function of the equation, blah, 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 blah. All right, so the general equation for this was y equals b times, I'll call this one sine, x minus h over a, and all these things stand for something, plus k. All right, the easy ones are the k and the b. K is how much vertical shift we have, and b is the amplitude. So amplitude is kind of easy here. This is half. Vertical shift is 3, which is no big deal. The tricky part is this stuff, horizontal shift and period. Well, the problem is this doesn't look like x minus something over something else. We have to change this so that it's x by itself with no coefficients added or subtracted with something divided by whatever that coefficient probably was. All right, so we have 2 pi x minus 1. I got to manipulate this 2 pi x minus 1 so it's sort of into that format. I can call that, I can divide everything by 2 pi in this thing, and that will get rid of this x here, which is great. But if I'm going to actually, you know what? I need to write this another way. It'll look like that in the end. Okay, I can call this. Let me distribute it out. Let me divide it out like this. This would be 2 pi, otherwise it won't be equivalent. 2 pi times x. When I multiply 2 pi times x, I get that, great. But I also need to have 2 pi times something over here so that when I expand it, it turns into -1. Well, what 2 pi times what is -1? Or 2 pi times what is 1? Well, that would be the reciprocal here. It would be like 1 divided by that. So now if I distribute this, 2 pi times x, 2 pi times this monster, I'll get that, which is great. Okay, I'm closer. This is starting to look like x. All right, so this is the same as 2 pi times this thing is the same as this thing. By this thing, I mean this. Divided by the reciprocal of that. That's what I meant to do at the beginning. 1 over 2 pi. So that's h and that's a. They look disturbingly similar, probably because that's just a 1 there, and it's going to kind of make 2 copies of itself. So that tells me that h is 1 over 2 pi. Because remember, it was x minus h, so this is h by itself. Also told me that a is this one down here. It's 1 over 2 pi. But that's not the period. Okay, so horizontal shift, I'm done. Horizontal shift was 1 over 2 pi. Great. But the period is 2 pi, coincidentally, times the absolute value of a. Okay, well, I know what a is. A is 2 pi, so period is 2 pi times a, and a is this. 2 pi times 1 over 2 pi is, guess what, in the whole grand scheme of things, 1. So if we had written our things a little differently, we might have been able to figure out that this is, there's a way to see that this 1 here is going to be period, but that's really tricky. It's not the way I taught you. Be careful about that. At this point, you should just kind of think of this as a huge coincidence. All right. That was Chapter 4. Chapter 5, I did this in class. You can take a look at this, especially if I don't see you till Monday. You might want to think about what you're going to ask me. Oh, by the way, I'm going to load up this video right now, obviously, and then I'm going to see how many views it gets. I realize you don't have any of my finals, FST finals, till Thursday. If this is getting lots of hits, then, you know, by like Monday or Tuesday, I might be persuaded to like, okay, I'll make some more of these. But unless I see that it's getting lots of traffic, or if you email me, those few people who are watching this going, ooh, this is really helpful, that would also sway me to make more videos. Otherwise, I think I've given you lots of stuff. Anyway, if I get a lot of emails and or hits on these videos, I'll make more. All right, here we go, chapter 5, some more that's not the stuff I was going to talk about in class. In this triangle, yeah, a lot of people miss this on the test. Notice I'm picking questions that I think are most test-like from the uploaded ones. I'm picking the ones that I think are going to be most helpful for studying on the final. All right, in this triangle, that's a C. It's a really funny-looking C, but there it is. Find BD. This is what we're looking for in the A end. Okay, round your answer to the nearest tenth. That's from a movie. All right, the trick here is we've got to figure out some of these angles up here. If this is 47, this is 43. And if this is 23 in this right triangle, this whole thing would be 67. 67 minus 43 is, well, I could just do this here, just so you know what I'm talking about. If you see this in print, you'll know what the 67 is about. That whole thing is 67. 67 minus 43 is 24. That little part is 24. This is 43 because the whole thing is 67. I know this is 14. I know this is 24. I'm thinking about the triangle in which I sort of care, which is BDC. I now have two angles and one side, and I need to know this other side. I know 24 and 14 are opposite. I know 23 is opposite the one I want to know about, so I think this is a perfect time for law of sines. Sine of 24 over 14 should equal sine of 23. It'd be really close to 14 then, isn't it? 23 over the thing I want to find. So that's it, and I do this on proportions. Sine 14 times 23. 14 times 23 divided by sine 24 is going to be what I need to find for x. And that is, fancy schmancy new calculator says 14 times, oh, am I in degrees? I'm probably not in degrees. Oh, it says you're in degrees. Oh, nice. Okay. 14 times the sine of, which one first? 23. Get back to it. 23 divided by the sine. You like this new calculator yet? Sine 24 is, and looks exactly like I want to do it. Oh, and look, there's no exact value, so it just does that. I go Control Enter, and it gives me a decimal. 13.45, because I knew it was going to be close to 14. Okay, great. Give the general solution to this. Okay, I hope I have enough room here. 4 cosine theta plus 2 equals 0. Okay, general solution, because remember cosine theta, the value of this keeps returning to the same number as we cycle through the cosine wave. Whatever value it needs to be, say it's that value right there, it's going to keep hitting that value in a number of places. So there's a lot of solutions to this, so that's why it's asking for general. There's an infinite number of probably 2 root values in their pattern that they generate from that. So let's just see what the cosine, of theta is supposed to be. Let's call that x. Let's just say 4x plus 2 is supposed to be 0. Oh, I wonder if the calculator will do this. I bet it does. Okay. Looks like x is supposed to be negative half. So we're supposed to figure out all the times when cosine is supposed to be negative half. Now you can either think of this as the wave kind of thing here. You can think about this as the unit circle. Cosine is the x value, right? And we keep going around and around this circle. Cosine is going to hit negative half. We're talking about the x value. So cosine is going to hit negative half sort of here and here. Every time the circle goes, or your angle goes past here or here. Yeah, so cosine was negative half at sort of, and it didn't say radians, but when it says theta, it sort of implies that we're talking about radians. Cosine of an angle being negative half, that's at the thing, it's kind of like, this is really small, isn't it? This angle is sort of like 60 degrees here, so in other words, this is really like 150 degrees, you can think of it that way. 150 degrees in radians, that would be 5 pi over 6. Yeah, so this happens at 5 pi over 6. Really? Not going to write for me? This also happens at, run out of space. This also happens at this one down here, which is 60 degrees off of 60 degrees off of straight down, so 210, or 7 pi over 6. Plus, then it's also going to happen at any point like 2 pi beyond this. So I should probably rewrite this. It's like 5 pi over 6 plus, and this was always the way these went, 5 pi over 6 plus 2 pi any number of times. And we'll do it at the end. 7 pi over 6 plus any copies of 2 pi after that. Oops, I just did that in the calculator and I realized I did something wrong. First of all, isn't this cool? I did it in radians, or degrees first. I did it in radians. If you do this in radians in the calculator, just say, solve this for me, please. It does that. And looking at that closely, realize I did this wrong. This isn't 5 pi over 6. This isn't 150 and 210. I had those wrong. That's, I was off by 30 degrees, and that's an easy mistake to make. This is 120. It's 30 degrees past 90 and 30 degrees before 270. So this isn't 5 pi over 6. Sorry, it's 2 pi over 3. That's 2 pi over 3, and this would be 4 pi over 3. Sorry. My reasoning was good. It's just my estimation of where cosine hits half is wrong. So, sorry about that. Okay. Sue me. Alright. Chapter 7. It's been a while. It's been a couple months. You know what? So I'll be nice when I grade your test. This one I do in class from Chapter 7. Here's something from Chapter 7 I didn't get time to get to in class. Determine the number of permutations. Okay, there's a hint. Of all the letters in the word 1, 2, 3, 4, 5, 6, 7, 8, 9. How many ways can you rearrange these 9 things? Well, probably this many. Or if you wanted to really bank on the word permutations there, it's 9p9, which is 9 times 8 times 7 times 6, blah, 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 blah. 9, and I figured it out in here. It's under 5. It's the top thing. And 9 factorial is that huge number, 3, 6, 2, 8, 80. You should probably memorize that eventually. Okay, and that's a comma. How many of those begin with TH? Well, one way to think about this, and one way to think about why this is 9 factorial, it's like you have 9 letters to put in boxes here, and you got to think, okay, well, how many choices are there for the first one, and how many choices are there for the second one? There were 9 choices for the first one, and then 8 after you do that, 8 choices, blah 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 blah, all the way down to 1. This one, how many choices are there for the first letter? 7, 8, 9. Really, it has to be a T, so there's only 1 choice for that. And how many choices are for the second letter? It has to be an H. That's it. After you do that, how many choices are there for the next one, etc. It's just going to look like this. So really, this is just 7 factorial, which is that thing divided by 8 and divided by 9. But you know what? I'll just do 7 factorial. 7, menu, probability, top thing, go. 5040. Okay, great. All right, minute and a half left. Suppose in one farm's apple harvest, disease X occurs in 2.5% of the apples, disease Y occurs in 1.6% of the apples. Are they independent? Independent means you could actually multiply them together. If disease X times the probability of disease Y actually equals, this is a question mark, the probability that it's in both, then yes, it'll be independent. Probability that's in X is 2.5%. Probability that's in Y is 1.6%. If you actually multiply those things, what do you get? 0.025 times 0.016. That's a 1.16. You actually get that percentage. That's exactly what they are. So yes, that equals 0.04. Yeah, I should put 2 more zeros here. So yes, independent. Okay, I think that's it for the chapters I even covered in class. This is 8. I didn't get to it in class at all. You know what? I'm almost out of time. I think I will start a second video, and this will be the first thing on there. Okay, starting with chapter 8.